Okay, my name is Kenneth and welcome back. So we're going to be talking about basics of routing, right? We're going to be exploring what routing is and the main types of routing. We're going to be talking about static routing and dynamic routing mainly today. So let's go ahead and get started. I've done a sample diagram that is going to help us understand what routing is on draw.io. So let's get started. So here you can see three devices, right? So 1, 2, and 3. This is the symbol that you would usually use to represent a router, right? So if you were making a project or designing your network, this is the industry standard symbol that is used to represent a router. This is the 3D look of what it would usually look like, right? Yeah, so that's it. So now we have three routers and we have three switches. Basically, we are looking at three different networks. I've also done the same network inside of Packet Tracer, and we're going to take a look at what it looks like in a few minutes. Let me log in, and then we're going to see what it looks like within Packet Tracer. Okay. So I'm successfully logged in, but before we get there, we're going to see the definition of what network routing is. So routing is a process of choosing a path for network traffic, right? So if there are one or more paths to a specific location on your network, to a specific network, routing would help your device choose the best path to that network. Routers use routing tables to determine the best path. Another thing is there are two main types of routing, that is static and dynamic routing. Now routers work in this manner, right? So firstly, the PC sends the packet through the switch to its default gateway, which usually is a router, right? So router would usually look at its routing table and figure out what is the best path to send out this traffic on. So you can send it to another router or the destination where the traffic is going. So depending on how the network is set up. Now, each router checks its routing table, forwards the packet to the next hop, and the process repeats until the packet reaches its destination. So this checking of routing table repeats until the traffic gets to its final destination. Now, IP packets have certain things they need to determine where they are going to. So firstly, there is the source IP address. So that is where the traffic is originating. Sorry, give me a minute. Secondly, there is a destination IP address, which is where the packet is destined for or is going to. And thirdly, there is the TTL, which is the time to leave. So a packet is not allowed to traverse the network indefinitely. There's a specific time in which if it doesn't get to its destination within that time, the traffic is, destroyed or eliminated within the network, right? Or dropped rather. Next one is the routing decision. This involves looking at the routing table to determine the best path for the traffic that is being sent. Now, looking at the types of routing, we have static and dynamic routing, right? So for static routes, they are manually configured on routers, right? So they are good for small and stable networks. Small in terms of networks that there is a little to no future growth, anticipated. So small networks that are stable. Another one is no bandwidth or CPU overhead. So because the router does not have to go through its routing table to take a look at what is the best route or decide, there is no CPU overhead because the route has been statically configured and the route knows where each packet is going to. Doesn't auto adjust to network changes. So if network changes tomorrow, if we add additional networks, additional routes, a static route doesn't know about that. Next one is the standard configuration for static routes is what we are seeing here. This is for a Cisco device, obviously. So you have IP route, you have the destination network, you have the subnet mask, and then you have the next hop IP address. So this is how you would put it in a Cisco device. So you specify that it's an IP route, then you specify the destination network with its subnet mask. So for instance, if we wanted to go to 192.168.2.0 on a /24 subnet, we'll send it out on the port that has 192.168.1.2. So this is how a static route is configured on a router. Next one is, what is dynamic routing? Now, dynamic routes are routers have routing information automatically using routers share routing information automatically using protocols, right? So we have routing protocols that we can define on a router, and the router will, based on this routing protocol, would share its routing information irrespective of how many routers exist within that network. If they have 5, 10, 15 routers, once they have dynamically configured routing, they would also share the information to each other, right? It adapts to changes. So if there are failed links, wire cables that are bad, it's going to automatically adapt and choose the best path to whatever destination network it's looking to go to. Next one is, requires more CPU, memory, and bandwidth, because the router and the device has to decide, what destination each packet has to go to. This is obviously requiring more CPU and more memory for this to execute. So common routing protocols that are dynamic that you would see are RIP, Routing Information Protocol. Another one is Open Shortest Path First, OSPF, Border Gateway Protocol, and EIGRP. So these four are the main ones that you would see out there, right? So we have in this video, we're just going to be taking a look at one of them, and we're going to be looking at static route as well. So on the dynamic part, we'll see OSPF. So OSPF is Open Shortest Path First. We're just going to look at the basics of how to configure OSPF because this is a basics video, right? So OSPF routing is defined by going into your configuration and typing in router OSPF1, and then you define the network, its wildcard mask, and then the area the area for that route, right? Now OSPF router 1 here is the process ID of this OSPF process. Each OSPF process has an ID that defines it uniquely on the device, right? Now the next one is the network. So you'd have 192.168.1.0, 0.0.0.255 area 0. So this is the wildcard mask telling you that it is a /24 network, and then the area is area 0, which is the backbone area. First of all, you match interfaces IPs. So this is a specific interface, and now you tell the router which network to advertise. The router is obviously advertising this network. Area 0 is the backbone area. Then we can use these to confirm that we've configured it correctly, right? Show IP route OSPF, show IP route OSPF neighbor to see the neighbors that have been created by this OSPF process, and then show IP route to see that it is populating various routes into the routing table. Now there's something we call administrative distance in routing. It is very, very important. This is the trustworthiness of a route source. So if a route is sent to a router dynamically, the administrative distance is what tells the router how trustworthy that route is. By trustworthiness, it means that the router is going to prioritize based on the administrative distance of that route source. So we have a couple of them here, right? So we have connected. If the route is directly connected to the device, to the router, the administrative distance is 0. If the route is a static route, just like we've seen here, the default administrative distance is 1. If it's an EIGRP route, just like we saw here, the administrative distance default is 90, and if it's OSPF, there is administrative distance of 110. BGP, RAPE, and other routing protocols also have their various administrative distance. So if we had these 4, which one would the router prioritize? Obviously the connected route, right, first, then the static route second, because it has a lesser administrative distance. Then it would use the EIGRP next before it uses the OSPF. So it's going to prioritize the one with the lowest administrative distance to choose as the path to a destination. Now we've gone through the basic theory of routing. Let's take a look at how to configure this routing within our device. So today I'm making use of Packet Tracer because I can use multiple devices, right, and test multiple devices at the same time. The number of physical devices I have are not a lot, so I don't have enough physical devices to test after I've done the configuration. Now if we go to, I want to find where I've saved my work. So Cisco Packet Tracer. Alright, now in Packet Tracer we can see that what we have here is similar to what we have in our draw.io. We have 3 routers and we have 3 networks, right? So I'll just put this side by side here so that we see the commands as well. Okay, good. So we have 3 networks, which we have 3 routers rather, and we have 5 networks here. So this one, this and that one, these are 5 different networks, right? So if we were to define a static route, let's say from router 1 to router 2, and we want PC0 and PC1 to communicate over the static route, I'll just duplicate this diagram so that we have 2 of it. So this one is going to be right here. So let me just ensure that I just want to ensure that the configuration is the same. So that's correct. So we're going to use the static route on this one, and then on the one on the right we're going to do the dynamic route on that one. So for instance, if we wanted to do a static route from PC0 to PC1, we already know that here the static route command says IP route, destination network, and a subnet mask, and the next hop IP address. So what we are going to do here is we're going to configure this device, the router 1, to have a static route to PC1. So if we wanted to do this, we need to go to our CLI, go to the router, go to the configuration mode. Let me increase the font so it's more visible. So I'll take it to 14, apply, and I'll close this out. And when I come back here, it appears to be the same size. Option, preferences, font. Oh, I changed the wrong thing. So I'll change this back to 8 and change this to 14 and apply. And close out from here and come back here. we should have it bigger now. So if we go to the configuration mode, right, and then we're going to configure a static route from here to here. So we're going to say IP route, right? So it's going to ask us for destination, right? The destination where we are trying to get to. Now we are trying to get to 192.168.2.0 network. So our destination is 192.168.2.0 network, and our subnet mask is 255.255.255.0, right? And then the next hop IP address is the IP address of this. This is the next hop because we are configuring this. So this is the next hop IP address. So we're going to confirm the IP address, and that is the serial interface, and that is, let's see what serial interface that is. View, options, preferences, always show port labels, turn that on. So we're looking at interface 0/1/0. That's the serial interface, right? So when we come back here, no, we're on the wrong one. We'll come back here. So the next hop IP address is, let's confirm, so 0/1/0. The serial interface has the 12.2 IP address, so we'll do 10.0.12.2 and we'll enter that, and then we've done our static route to this location, right? But since we've done it on this router, we still need to do the same configuration on this router to route the traffic back. Now the traffic can go this way, but coming back will be an issue because this router doesn't have that route back to the preview to the other router. So now what we'll do is we'll go to our second router, which is this one, and we'll do something similar there. So we'll go to the configuration mode, and on the configuration mode what we're going to do is IP route, and then it's going to ask us to enter our destination again. Now our destination will be different because we're going to this network. So our destination now would be 192.168.1.0. Subnet mask will be the same, 255.255.255.0. Now our next hop would also change because now we are going the other way. So the next hop address would be, that should be 12.1, right? So we'll do 10.0.12.1. That is our next hop IP address. Now that we've done that, let's confirm that we've done the right configuration, right? So we're going to do show IP route, right? Now we can see that we have a static route which is identified by the S here. We have 190.168.1.0/24 via 10.12.1. Remember, we are on router 1, so it's going to send it to 12.1, right? Via 12.1. So this is our static route. Now that means it's going out through this interface of 12.1. So we have some directly connected networks, which you can see here. These are directly connected. So we'll close out from here and try to do a ping from PC0 to PC1 just to ensure that our static route works. So we'll do ping 192.168.2.2, right? So we'll let that happen, and then we'll see the result. So obviously the first one fails because it's going to time out. Maybe it takes more time to find out where the network is, and the network's probably still converging at this point in time. So, but when we try it again, it shouldn't fail, right? So it's completely successful on the next one. So note that in configuring a static route, you have to configure it both ways. So you have to have a route to and a route from. So we've configured it this way. Now we'll configure it backwards for it to work perfectly. So that's about static route. We could do the same thing for this entire network, but it's going to exhaust our time for this video. Now let's try for the dynamic routing. Now for the dynamic routing is somewhat different, right? So for the dynamic routing, we're going to specify the routing protocol we're going to be using, and then secondly, we're going to advertise different networks. So I'll start from router 1, right? So I'll go in there, and then we're going to be using OSPF just like we said, right? Now I'll go to router 1 and I'll say router OSPF 1. So sorry, I need to do this in the configuration mode, right? Config T. Now router OSPF 1. So this is the process number and this is OSPF. So OSPF is running now. Now we have to advertise the networks that we want to be part of this OSPF process. So network, so we're going to, on router, this router, we're going to advertise this network and this network. So what we're going to do here would be network 192.168.1.0, and then we're going to give it the wildcard mask, which is 0.0.0.255, and we're going to put it in area 0. Right, now we press enter and that has gone through. Next one, we're going to do our wildcard mask would be 3 because we have 255.255.255.252 for the 12 network. So 12, 0 and 10. So we are doing for this one, which is 10.0.12.0, and it's /30, which is 252. If you subtract 252 from 255, you'll be left with 3, meaning that the wildcard mask would be 3, right? So area 0. Now we've put that in and it works. Now that is to say that we are done configuring the first router. Now let's go to the second one. Now the second one is en conf t, and we're going to configure this one first. So we're going to say router OSPF 1. We're going to say network. We're going to say 10.0.12.0 wildcard mask 0.0.0.3, and then we have area 0. Now that has gone through. We're going to try to advertise the other network, right? So let's advertise the 23 network, since the configuration is almost the same. So we'll advertise the 23 network as well, right? So this is for the 23 network, 10.0.23.0. Now let's advertise for this network, the .2 network. So it's also in area 0, but this time it will be 255, and the IP address would be 192.168. Right, so now the IP address is network 192.168.2.0. we have the wildcard mask, and we have the area which is going to be in. So we have advertised the 3 networks, and you can see as we were configuring, we had this come up showing that serial 0/1/0, which is this one, from loading to full state. OSPF rather has various states that it can be in when it's trying to establish a neighbor relationship with the router connected to it, right? So we can look at all of that in another video, but this is just a basics video. So it's moved from loading to a full state, and it says loading done. So now there is connectivity between these 2 networks, right? So let's take a look at pinging from here. So if we go to desktop and command prompt, and we do ping 192.168.2.2, let's see it work. First one fails, second one works, right? So now you can see that we have connectivity between here and here, right? And remember, we've also added this network, and we've added this network, we've added this network. So let us try pinging one of these networks, right? So let's ping 10.0.23.1. you see it's working, right? Because this router is going to advertise this route to this router, because it's a dynamic routing process, right? It's going to advertise all of its routes to this neighbor router. Now let's go back and see their routing tables and see what's going on in there. If you go to the routing table for this one, what you find is, so let's exit, and then let's show IP route. Let's add a do. Now if we do show IP route, we'll see that we have an OSPF route, right? So this router has learned this, has also learned that there's a 23 network, but how did it learn it? It learned it via 10.12.2, which is this guy right here. He learned it from this guy, that there is a route called 23.0. He learned it dynamically. So the difference between dynamic and static routes is that dynamic routes can be shared without you entering it. So if we had more networks, for instance, if tomorrow the company is expanding, right, and tomorrow we get a couple more routers, right, and we have a different floor or a different branch, whatever it is, and we add it, I'll just make this, and we add it somewhere here, right, and we want to connect it. We connect these 2 networks, right? All we need to do, right, is when we connect it, we just need to configure on one of the routers and configure and we add a network keyword, right? We're going to add a network keyword just like this one, network keyword, right? Add a network keyword, and once you add that network keyword, it's going to take a few minutes, but the routers are going to share this routing information amongst themselves, and they will all be updated as to the new network that has been added, right? So that is very important to know. Now on other devices that do not have that, whereas you can't use, you can also use command line on other devices where you can have GUI, there are also ways that you can configure it, right, on your GUI. So if I come here and I type in my password, and we wanted to configure routing on this device, this is my Sophos SG210 firewall. You can also configure routing on firewall devices. So if you come to configure here, you'll find routing. So under routing, you will see the various types. You have the various types of routing configuration that you can perform here. You can even perform RIP and all of that. So you have OSPF here. Now on OSPF, you can configure your router ID. That's the router ID of that particular router, and then you can configure the network, right? You can add the network that you want it to advertise just by clicking on add, and then you add in the network and the subnet mask here, and then put in the area you want the network to be in, whether it's your backbone area or a stub area or whatever area it is that you want to configure, right? You want to configure it in. So that is basically it. You can do this on firewalls, you can do this on GUI, you can do this on CLI. So the basic things that you need to know about routing is you need to know your source, where you're starting from, your destination IP address, be it a static route or a dynamic route. You need to know your source IP address, your destination IP address. Another information, although we didn't use it in this video, is the administrative distance. You need to know the administrative distance of the route you're trying to configure, and then you need to know the routing protocol it is that you're configuring, whether you're configuring RIP, OSPF, BGP, EIGRP. So it will take you more in-depth understanding, studying, and knowledge about these protocols to know which one is required or which one would be preferred for whatever network topology or architecture that you're trying to deploy. So thank you very much for watching. I'm sorry I couldn't use my camera today. It's a bit faulty. I have to get a replacement or find out what the issue is. Yeah, but if this video has helped you or made sense to you, please do like, share, and subscribe, and drop me a comment if you have any questions, or if you like to have a one-on-one, then come in the comment section or send me a DM and we'll get that done. Thank you once again for watching, and see you on the next one.